What is the oblique asymptote for this rational function? Oblique asymptote is the same thing as a slant asymptote. So that's what we are calling it. You find the slant asymptote. First of all, it happens when the degree of the numerator is 1 greater than that of the denominator. So here we have degree 2 and degree 1. So this is 1 greater, so there should be a slant asymptote. So you find it by doing long division. So we're going to do x plus 2, and we're going to divide that into your x squared minus 3x plus 2. So the first thing you do is you take the first term of each and you divide. So you take that higher degree 1 and you divide it by that lesser degree 1, and that turns out to be x. So that's what you put up here. And then you take that and you multiply with it. So x times x is x squared. X times 2 is 2x. But then you subtract by changing the signs. So this will be minus, and this will also be minus. So these cancel out. These make negative 5x, and this just comes down as 2. And then you do that over again. Alright, so we're going to take this one and divide it by this first term. So that's going to be negative 5. So that's what comes up here now. And then you take the negative 5 and you distribute and you multiply. So you're going to get negative 5x minus 10. You would subtract by changing the signs. So that's going to give you a remainder of 12. Okay, so the remainder does not get involved when you're doing the slant asymptote. So the slant asymptote is just going to be this part, y equals x minus 5. The remainder of 12, there should be a remainder. If you ever had a remainder of 0, that means that the denominator cancels out, and so it would be a whole. So you do want to see that there is a remainder, but other than seeing that you have a remainder, it does not get involved in the slant asymptote. So the answer is B.